Hello, welcome to Newton's Laws and Forces, the first in a series of videos, and in this video we're going to look at what is force. Now, we've already mentioned forces when we did vectors and a few questions in the process when we did momentum. We've looked at forces, but we might just recap and make sure everyone's on the same page as to what we mean by force. And so we can say that a force is either a push or a pull on an object. Okay, and we know that the unit is a Newton, and we know that it's a vector quantity, so that means it usually has a direction and a magnitude, but we're not 100% strict on the direction, because sometimes questions are not very specific, and therefore the direction is not given. And so what do we mean by a force? Well, what is 1 Newton? If you held 100 grams, so that's a bit less than half a Mars bar, in your hand, you would be feeling 1 Newton of force. There you go. Now, we need to know the difference between balanced and unbalanced forces. And so, because objects can experience more than one force, we need to work out whether or not, how they're acting at each other and on the object, and whether it's balanced or unbalanced. And so if the forces cancel each other out, they are referred to as being balanced. So right now you're sitting on a chair, your mass is creating a weight force on the chair, and your chair is pushing back with an equal but opposite force, and so you're not going anywhere, you're just sitting on that chair. So we would say that the forces of you sitting are being balanced. Here's an example. Here's a trolley, and it's being pulled 3 newtons to the east and 3 newtons to the west. Forces are equal, therefore no acceleration. And in this case, if the body was already stationary, it would stay stationary. Now, this, to complicate things, let's imagine if this trolley was moving and we applied these two forces. Well, again, the trolley would just keep moving at the same velocity. There's no acceleration. The forces cancel each other out. Now, if the forces don't cancel each other out, we call them unbalanced. That makes sense, doesn't it? And so here we have 3 newtons to the west and 5 newtons to the east. So we should be able to do that in our head and work out that there's going to be 2 newtons to the east, and that is going to mean that the forces are unbalanced, and therefore we get acceleration. This trolley would accelerate to the east. Now, the term net force we've also used when we were looking at vectors, and it is the vector sum of the forces acting on an object. And usually we only talk about 2 forces, but in the reality of the world, objects can be pulled by innumerable forces. But we simplify it down for us in physical science. So now, the normal reaction is the force that acts perpendicular to a surface as a result of an object applying a force to that surface. So if I put a book on a table, the normal reaction force is the table pushing back perpendicular to the surface of the table. Let's have look at a few of those examples. Okay, so here's someone sitting on a chair. There's a weight force, okay, down due to gravity, and the chair and the earth must be pushing back to equal this force down and cancel it out. And so you can see that if this was the surface, alright, let's choose a different colour. Actually, let's make it a little bit bigger. If this is the surface that you're sitting on, and perpendicular to that surface is the normal. Okay, and the same with the ground. That's the ground. To be perpendicular to that surface is in that direction there. I could have picked an even better colour, couldn't I? Orange. Yep. And so all these forces up balance out these forces down, and we end up with not going anywhere. Alright. And another example. Couple of examples here. Here's an apple in a tree. Now, if the apple is just stationary, hanging there by the tree, all the forces are balanced. And so we give the symbol W as the weight force of the apple, and B is the pull of the branch, or that would be the reaction force of the tree to the weight. Okay, and that means the net force is 0. In this case, the apple is falling. The weight force remains the same because it weighs the same basically, but it doesn't have a branch holding onto it, so there's no upward force for that. There's only air resistance, and air resistance we'll talk about later in more detail, but air resistance is proportional to how fast you're moving through the air. So in this case it's not moving that fast, and therefore if we add those two vectors together we get this net force, and therefore it's accelerating towards the ground. Adding forces together, we did this in vectors, pretty straightforward. Here we've got two forces in black, 30 newtons and 40 newtons. We should be able to put one of these head to tail, or just do it in our head, and we get 70 newtons as the net force. Bit more difficult if they're pointing in different directions. Again, head to tail technique if you're uncertain, and you get 10 newtons to the east. So, example of that, pushing on a box, 4 newtons and 3 newtons. In this case the box would move and accelerate due to a force of 7 newtons. In this case the box experiencing two forces in opposite direction. The resultant of this is 1 newton to the right, and therefore the box would move to the right. And forces don't have to be in the same linear plane, they can be acting in angles to each other. So imagine this is you and you're being pulled by two ropes by your arms, and one is being pulled at 30 newtons, one's being pulled at 40 newtons. We could draw the triangle, and let's just pick a nice colour, purple. And if we drew our triangle, we bring this one across to here, head to tail of course, that's 30 newtons, and we'd work out that angle. That's a right angle, so we use sine, cos and tan and Pythagoras theorem to work out the resultant. Okay. Types of forces. Well, gravity. We feel gravity all the time. We're not going to look into too much detail into gravity. If you do physics next year, we'll look into it in more detail. It's quite interesting. Electrical forces can occur. We can have magnetic forces due to magnetic fields. Tension is a force, so if you pull back on a rubber band or an arrow, a bow rather, you get tension. Upthrust is a force, that's what keeps planes in the air. Resistance is a force, so air resistance or all sorts of different types of resistances. And there's a thing called the nuclear force as well, which holds atoms together. And this is just a short list. There's multiple different types of forces out there. Friction is also a force. Now in the next video we're going to start looking at Newton's laws, and they have to deal with forces, and so that's why we did a quick little introduction on forces. So next video, Newton's first law. See ya.